Welcome to Daily Papers.
We tend to think of artificial intelligence as this hyper-rational, logical entity, something that follows rules and checks its work meticulously. But what if these powerful AIs have a blind spot? What if they're actually really gullible?
Today's paper, An Enigma of Artificial Reason, investigates a strange quirk in the world's most advanced AI models. It turns out they can be brilliant at solving a problem, but absolutely terrible at grading someone else's solution. It's like having a star student who's incapable of peer review.
Let's start with a human comparison. Think back to your school days. What did you find easier, solving a complex math problem from a blank page or looking at a friend's completed work and trying to spot a mistake?
Oh, definitely spotting the mistake. It's much easier to critique something that's already there than to create it from scratch. And psychological studies on human reasoning agree. We are generally stronger at evaluating reasoning than producing it.
Exactly, but this paper found that for large reasoning models, or LRMs, the super advanced AIs that power many of the tools we use today, it's the complete opposite. They're phenomenal at producing step-by-step solutions to math problems, scoring nearly 100%.
But what happens when you ask them to put on their teacher hat and evaluate someone else's work? That's where they completely fall apart. The researchers found a massive production evaluation gap. The AI produces work like an A+ student, but evaluates it like it hasn't had its morning coffee.
So how do you actually test this? This is where the researchers got really clever. They designed a special set of problems specifically to trick the AI. They called it the VARE dataset.
VARE stands for Valid Answer Invalid Reasoning. That name tells you everything you need to know. These are math problems where the step-by-step logic is completely wrong, but the final answer is somehow correct.
Imagine a problem where the final answer is 19. The solution they show the AI might have all the steps jumbled into a random, illogical order, or maybe a critical step is just completely missing. The reasoning is a total mess.
But, and this is the crucial part, the very last line of the solution triumphantly declares, therefore the answer is 19. The final answer is right, even though the journey to get there was nonsensical.
When the researchers gave these tricky VARE problems to top-tier AI models, the results were astonishing. The AI's accuracy, which was nearly perfect when solving problems themselves, plummeted to as low as 48%. Almost half the time, the AI would look at this garbage reasoning and say, "Looks flawless to me, full marks."
For comparison, they also tested humans. We weren't perfect, but we correctly spotted the flawed reasoning about 75% of the time. We're much less likely to be fooled just because the final answer looks right.
So what is going on here? Why are these supposedly super intelligent AIs so easily duped? The paper argues it all comes down to something called answer confirmation bias.
It's a bit like a detective who decides on the culprit first and then tries to make all the evidence fit that conclusion. The AI sees the correct final answer, which it can easily calculate for itself, and then it just works backwards, assuming the steps that led to it must be correct.
The researchers actually looked at the AI's chain of thought, which is kind of like its internal monologue as it's working through the problem, and they found that's exactly what it does. Instead of carefully checking the provided steps one by one, the AI often just solves the problem independently on the side.
It gets the right answer, sees that it matches the answer on the test paper, and then it just rubber stamps the whole thing. It even makes up excuses for the flawed logic, writing things like, "The presentation is a bit disorganized, but all the reasoning is mathematically correct."
It's a classic case of focusing on the destination and completely ignoring the journey. The AI is so good at getting the right answer that it uses that as a shortcut to judge the reasoning, and fails miserably.
This is where the paper gets really wild. To prove that the correct answer was causing this bias, the researchers performed a kind of digital brain surgery on the AI. The technique is called causal patching.
They would give the AI a VARE problem, flawed steps but correct answer. Then, as the AI was processing it, the researchers would jump in and essentially hack its brain. They would find the part of the AI's internal network that represented the correct answer and swap it with the representation for an incorrect answer.
It's like leaning over the AI's shoulder and whispering, "Psst, you know that answer you think is right? It's actually wrong."
And the moment they did that, the AI's entire behavior flipped. It suddenly became a much harsher and more accurate grader. It would say, wait a minute, the final answer is wrong, and now that I'm looking closely, these steps don't make any sense at all. It correctly marked the reasoning as flawed.
This was the smoking gun. It proved that the mere presence of a correct final answer was directly causing the AI to become lazy and biased in its evaluation. Take away that correct answer, and the bias disappears.
So while this is a fascinating scientific finding, it also has some pretty big real-world implications. We're starting to ask AI to do things like review computer code, check scientific findings, and even help write legal arguments.
But this research shows that AIs are trained to be expert answer getters, not expert reason checkers. The way we build them incentivizes getting the right outcome, not being vigilant about the process.
If our ability to automatically generate arguments in code grows faster than our ability to automatically evaluate them, we could find ourselves in a world flooded with convincing-sounding nonsense that's built on faulty logic.
It's a powerful reminder that even in the supposedly objective world of math and logic, AI has its own strange and very human-like biases, and we need to understand them if we're going to use these tools wisely.